Bye, kids. Hey, I got a bucket of water here. I got my, bucket of water here. And if I spin it, you'll notice that as long as I spin it fast enough, the water stays in the bucket. Now, if you spin it too slow, the water's going to come out. Now, I'm not going to demo that, but if you would like to, make a movie of that, by all means, make a movie of that. So, and that's what this little short video is going to be talking to you about, is going to be how do we determine, or what is the minimum speed for the marble just to make it through the circle, okay? So, I have a couple of other things that I want to show you. So, imagine I have this loop-to-loop, okay? Similar to like, hey, the water's moving in the bucket, but I have a marble going through a loop-to-loop. I want you to listen, okay? So I'm going to have the marble. It's not going to just barely make it through, but listen. Can you hear, using your ears, how the track is pushing on the marble the whole time? It's, as it goes through. So listen again. You can hear that the marble pushes on the track the whole time. Well, if the marble is pushing on the track the whole time, and I was asked you to draw an FBD for, eventually you're going to have to do for different points, but we'll do at the bottom and the top. Well, if I was going to draw that, hey, look, I got my board over here. So if I was to draw this, here's my marble. At the bottom, the force of gravity is acting on it. Now, it's moving in a circle, though. So therefore, it has to accelerate towards the center. Remember, that acceleration is called centripetal acceleration. Okay, the word centripetal means towards the center. So there has to be another force acting on it. Because right now, if that's the only force acting on it, it's in free fall. So what is that other force? It's the force of the track, the normal force. And it has to be bigger because it has to accelerate towards the center. So the net force has to point towards the middle. But if you listen, you can hear that the track pushes, in fact, the hardest at the bottom. You can hear where it goes, okay, at the bottom. So you can hear it, okay? Well, at the top, the gravity is the same because, you know what, it's the same marble. So there's still Fg, so this force and this force have to be the same. But when you listen, okay, the normal force gets smaller at the top. Now, I don't know exactly how small, but it's smaller, okay? Because the normal force can change. But you'll notice it is accelerating towards the center, okay? Centripetal, center seeking, okay? But I want to show you what happens at the minimum speed. So this is going to be, it's faster than the minimum speed. And you can hear the, okay? As I get closer to it, listen. Can you hear it? Can you hear what's happening at the top? You hear how the track is pushing less and less? And then until I get to the minimum speed, oh, did you hear it? Oh, did you hear it? That's right, I didn't hear it either. You want to know why? Because when you're at the minimum speed, the track doesn't even push on the marble. So it goes, which means that the marble at the top, the only force acting would be the force of gravity, so that the normal force would go away. So if you're at the minimum speed, the only force at the top, if it's a vertical loop, okay, is going to be the force of gravity, okay? Remember, we're not memorized, we're gonna understand it, make sure it makes sense to you, and there you go. All right, bye kids, now you get to try problems, bye.